Today we will first learn a special type of function in Python. We have already seen some specific task we can do using various functions in data frame. We have seen how different type of data structure works in Python. Now see the special function that we will learn today is what we call lambda function. So before we understand how exactly the lambda function works, let's understand first how a normal function works in Python. Just for example, suppose I'm writing a program for finding a square root of a number using function. What we will do, we will create a function, say for example find square, something like that, and which will take a variable, say for example x, and it will basically return just x into x, that's all. Here it ends. And if you want to use this function in your program, what you will do, you will say uh, call this function find square, and you will give some value obviously, and obviously you should, since it is returning something value over here, so you should have some value here, for example a equal to, and then you can easily print this variable result. Say for example result equal to a, something like that. And if you run this particular program, then what will happen, you will get a result 25 because your input was 5. So this is how a normal function works in Python. But you can simplify this particular job using what we call lambda function. It is nothing but another technique of writing those functions where we have a very limited amount of line, mostly in one or two lines the job is done. In those cases you don't need to write function separately, rather you can use directly lambda function. So let's see now how this lambda function works. See, if I want to use lambda function for do the same thing, I will not write a something like this type of approach. First of all, since although I am saying lambda is a function, but the way of expressing or way of defining the lambda function is not exactly same as how we define a normal function. Rather, what is the way we can do that? We write, say for example, we can write y equal to, then since it is a lambda function, we have to write lambda. So it's a keyword, that's why coming in valid. Then you can write, say for example x. What does it mean? It means that this x is nothing but acting as the parameter presented in this normal function. And what exactly you want? You want to get the square of x. So it is nothing but I will just write x into x, that's all over here. So by this just one line I'm representing a lambda function whose which will take input x and will return x into x, something like that. But remember, this y is not the output of x into x, it is actually the name of the lambda function, you can say. So that means instead of writing y, you can also use find square, just what we have written, something like that. But see, as I told you that this is not a function, so there will be no such opening and closing braces. Now when you will call this lambda function, then you have to use a opening brace and closing brace, something like this, because ultimately you want to pass some particular value in this x so that you can get the square of that. So the other part of the program remains same. There is no change. But the way of writing a lambda function looks something like this. And if you say, for example, run this particular code, again you see you will get the same result. But what benefit we got? We got just in one line we have represented this particular um, you know particular type of operation. That is the thing. Now, first of all, one advantage to some extent you can say that this lambda function minimizes the complexity in the code, in the sense that for very small set of lines there are, if you write a very complex code, and there you may have some functions whose functionality is very limited, and maybe you can express that functionality in a single line. In that case, what you need to do, if you don't use lambda function, you have to define a function name, and then you have to write in a single line return function, return statement. But that complexity can be resolved just by expressing the same by a lambda function, something like this. Now, how we can utilize this lambda function? We can actually utilize this lambda function anywhere, including in your data frame as well. So let's see how we can use this lambda function in a data frame and why it is required. So for example, as already we have seen that there can be many pre-processing required before we feed our data into a machine learning model, that I have already said in my previous classes. So now what are the different steps and what are the different scenarios can be there? We will go through in detail when we will start machine learning part. But before that, just for understanding the context, let's take a scenario presented over here. What you can see, so I have written a code here for you, just showing what is the use of the lambda function in pandas data frame. So as you can see here that I have two packages required, pandas and numpy, because I'm taking you know just a value list of values in an array, and basically I require to put this into a data frame, and that's why actually I've given something like this lines of code. And if you run only this set of lines, say if I just omit this particular variable for time being, and if I even clear all these variables, so and if I run this set of code only, what you will get, you will see that based on this list of values a data frame has been created here, right? And there is some set of fields, field 1, field 2, field 3. These are the column names and these are the indexes, and you see I have given specific indexes names like A, B, C, D, E, F, G over here by this particular parameter. If you don't use this parameter, there will be basically no change in the data frame. Only instead of having this specific index values, the index will be started from 0 to the n minus 1, where n is the number of data. So let's check it once again. So I have deleted this, and if I run this code, then what will happen? Let's see. You see the pandas data frame remains same, but if you look into this data frame, you'll see now here the index coming as 0 to 6, something like that. So there is no other changes here. So anyway, my index values is not very much important right now, because what I want to show you here is that how we can utilize this lambda function to change the data presented in the data frame. Okay, you see Here we have a very important function present that we can use in data frame, that is dot apply. As you can see, what is it actually? This dot apply functions actually applies on each and every cell of the data frame. And let's assume a situation that you want to, in the field 1, this particular column we have, total 7 values, and you want to do some pre-processing on this particular, column. And maybe this is a column, some certain feature for your, for your machine learning problem. So, and what is the pre-processing you want to do? You just want to do the square, that's all, nothing more than that. Okay, so what you can, like, if it was in some other language like in C, and if it was in a 2D array, then you had to go through each and every locations one by one, and then you need to go for a square operation on that cell, and you need to restore that. But here we have a apply function in the data frame, and in this apply function we can pass a particular function which will operate on each and every cell of the data frame. For example, since we know now how lambda function works, so what I have written here, I have written lambda x colon colon is required, then np dot square x. This np dot square is just required to do the square of this value. So that means whatever the input that this function will get will do the square. And now next question will come, that the cell from which particular, column? Is it from column 1 or from column 2 or from column 3 or from all the columns, right? You can have any options over here. For example, here we have taken only on column 1. So what this particular part will do as a whole, that it is saying that you apply this lambda function on this field 1 column, and for every x means for every cell present in the column, you do the square and return the square. So if you want to return the square, you must have something to return. For example, you see, if you go back to the lambda function, you had something a equal to something like that, right? Means that you are passing this value, and it will go, is the lambda function will be called because of this one, and this 5 will be passed in this x, and 5 squared 25 will be returned back in a. As simple as that, just like a function call. Same here also, this particular part will basically return a set of numbers, because in this field 1 column you have total 7 values present in the data frame. So basically it will return definitely, square of each and every value over here. So you must have something, some other column, or maybe the same column, where you can store this particular squared value. That is why what I have written here, you see, df within double square bracket field underscore 4. But you see, this field underscore 4 doesn't exist in this data frame. So what this Python will do, Python will create a separate column on this data frame whose column name is field 4, and will put all the result that it has got from this 7, squared value individually, and will put over there. So as a result, what will happen? The data frame will get updated in a sense that another field will be added, another column will be added, and in that column you will get square of all the values of presented in this field 1 column. So if you just print this particular variable, I'm just printing df, you will see you will get this value. So let's just see in visually over here. You see that you have got a field 4 column, and each and every element of this field 4 column is basically square of this field 1 over here. Now every time you may not require a new column in your data frame because you don't want to increase the column. For example, you want to do some pre-processing on a particular column, and after pre-processing definitely the old value is not required. In that case, what you can do, you can simply keep the same field name, and if you do this, what will happen, there will be no change. I mean, there will be change on the field 1 column directly. For example, if you run the whole code, as a result you will see that field 4 is not there, but field 1 is itself updated by the squared value of whatever value it has in field 1 previously. Now sometimes you may require, you know, the 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 updation or the pre-processing on the full data set, some pre-processing. Okay, so what are the list of pre-processing that we will come to later. Okay, just for timing, if I say that suppose I want to do the pre-processing in form of square for all the elements over here, in that case what you can do you need to write this for each and every column separately? No, you don't need to write that. Instead, what you can do, just I'm writing as an example here, that you can simply, I'm just copying it here and writing it here. You can simply write, without any specific column name, you can simply write the data frame dot apply. So data frame dot apply means it will be applied on each and every column. And if you want to apply on a particular column or particular set of columns, in that case within the square bracket you have to specify the column or list of columns. Anyway, I don't want to change my present data frame. So just I'm showing you with a new data frame df1. That's why I have written a df1 over here. And you see, if I don't, I'm just keeping it off just to show you that what's happening if I do the same thing without specifying a particular column. And if I just run this program, say for example up to this, if I run, okay, just a minute, let me just clear all the variable and whatever command we had, and I'm running this set of lines initially. So firstly, you see I have this amount of data presently. Okay, so this is my data frame, and what I'm doing here now, you see I'm applying the lambda function on this data frame, not a specific column. That means it will be applied for all the columns, and as a result, that means it will, all the column will be up squared, all the cells will be squared, and as a result I want to get stored in a different data frame named df1. So if you just run this particular command, this particular line, you see another data frame has been added having the same number of rows and columns and having the same column name because there is no change. And if you run this, if you just double click over here, you will see the data frame that you have got is nothing but, for each and every cell, it is nothing but square of the actual data frame. So this is how our apply function works in data frame, and within the apply function you can specify any function which will operate on each and every cell of the data frame, and this is extremely useful when we will do the pre-processing during machine learning problems.